Today we'll take a look at average rate of change. Sometimes we abbreviate this ARC. The idea is that for average rate of change, if we have a function and 2 points that are on that graph of that function, we call the average rate of change simply the slope of the line that connects those 2 points. So for the same function, depending on the points you choose, the average rate of change may or may not be the same. So remember, to calculate that using a slope calculation, we do, if the points are x1, y1, and x2, y2, we use the calculation y2 minus y1 divided by x2 minus x1. That's essentially your vertical change divided by your horizontal change. This is, again, in function notation, right? So if we start at some x value a and go to some other x value b, we can write those two coordinate pairs using function notation. One of the points, the beginning one would be a comma f of a, and the other one would be b comma f of b. So using those 2 points in that same slope function, we can come up with a slightly more useful, I guess, average rate of change formula. Right? We've got, instead of y2 minus y1, f of b minus f of a, your change in outputs, divided by b minus a, the change in inputs. That's going to be the way we'll calculate the average rate of change. So graphically, real quick, we've got a curve of some sort, looks like a parabola. And we've got 2 points on that curve, the point 0, 1 and the point 4, 3. Suppose we want to know the average rate of change between those two. Visually, all we're doing is we're looking at the horizontal change, which would be 4 minus 0. We're looking at the vertical change, which would be 3 minus 1. And we're dividing those two. Remember, the vertical divided by the horizontal. So we'd calculate, in function notation, f of 4 minus f of 0. That's the y value when x is 4, so that's 3, minus the y value when x is 0, that's 1. 3 minus 1, like we said, gives us 2. And we divide 2 by 4 to get an average rate of change of 1/2. That means that the slope between those 2 points, if we were to connect them with that black dotted line there, the slope of that line would be 1/2. So the average rate of change for this curve from x equals 0 to x equals 4 is 1/2. Another example based on a graph. This one is another parabola, it seems like, and we've got some points a little easier, maybe 0, 0, and 5, 5. If we want to know the average rate of change between those 2 points, simply calculate 5 minus 0 in both cases, and we get an average rate of change of 1. This one's slightly different. We've got another parabola, but it's been shifted. X minus 3 quantity squared is our function. We want to know the average rate of change between x equals 1 and x equals 3. So all we need to do, this time they aren't labeled, but we can read the points from the graph pretty easily, or we could plug in x equals 1 and x equals 3 into our function. Either way, right? So you don't necessarily need the graph here if you've got the function written out. We can calculate f of 3, that would be 3 minus 3, which is 0 squared, still 0. F of 1 would be 1 minus 3, which is negative 2 squared, to become positive 4. Again, or you could just see those points on the graph. So our y values would be 0 minus 4. Our x values would be 3 minus 1. So notice that's going to end up with something slightly different, right? We have on top negative 4, on the bottom 2. We can just take the negative out there. That should be a negative 2 though, right? The average rate of change is in fact negative 2 for this curve. And that makes sense because as we look at it from left to right, that dotted line has a slope that's negative. It's got a decreasing piece there. So it makes sense that the average rate of change is, in fact, negative 2 there. So another one, if we have the radical function f of x equals square root 2x minus 4, suppose we want to find the average rate of change from x equals 2 to x equals 4. This time we don't have a graph, that's okay. We can still just plug in those two x values, the larger one first and then the smaller one next, and subtract. So it'll look something like this. I wrote it a bit differently this time. We're not using that function notation in its own step here. We're just going ahead and plugging in 4 into the function, plugging in 2 into the function, and subtracting those two amounts. So a little bit of simplifying to do there. Work on the inside of the radicals first, and then simplify down. So it looks like inside there, 4 times 2 is 8. 8 minus 4 becomes 4, and so we have the square root of 4 for the first one. 2 times 2 is 4, minus 4 leaves 0. On the bottom, 4 minus 2 is 2. So this one works out nicely because the square root of 4 and the square root of 0 are whole numbers. It doesn't necessarily always happen, but in this case it's pretty nice, right? We get 2 minus 0 on top, So we end up with 2 over 2 for an average rate of change of positive 1. One last one, suppose we have this function, g of x equals 1 over x minus 5. So this is like a reciprocal function, a rational function, you could call it too. Suppose we want to go from x equals 10 to x equals 15 and determine the average rate of change between those two places. Again, not too bad, just plug in 15, plug in 10, and subtract those two outputs in the numerator. So I went ahead and started that here, right? 1 over, we're plugging in for x, those two x values. So 1 over 15 minus 5 minus 1 over 10 minus 5. And then in the denominator, remember, subtract the x's, 15 minus 10. So this one, a little bit of arithmetic to simplify, right? We've got, in the numerator, this is a complex fraction, right? We've got 1/10 minus 1/5, once we simplify those denominators, divided by 5. In order to simplify further, a common denominator in the numerator would help there. So find a common denominator between a 10th and a 5th, that would be 10. So basically just multiply 1/5 by 2 on the top and bottom to make 2/10. So simplify by subtracting then. 1/10 minus 2/10 becomes negative 1/10. And to divide that by 5, a trick you might have done before is instead of dividing by a number, you can multiply by its reciprocal. So take this fraction and instead of dividing it by 5, multiply it by the reciprocal, which is 1/5. That gives us an average rate of change of negative 1/50.